Hello and welcome to this video. In today's data driven world, we often encounter data that isn't perfectly structured. Logs, events, and API responses can be messy, and extracting meaningful insights requires us to shape and mold this data. Imagine you'll need to group related information into a single record, like multiple security alerts for a specific incident or a user's various activities within a time frame. Representing this as a JSON array object within a KQL result makes it easier to consume. It makes it more organized. It also makes it powerful for creating complex data structures directly within your queries. Today, we'll focus on how Backpack allows you to create JSON array objects that serve the above said purposes. I have my Log Analytics workspace open for showing you how the Backpack works. Backpack at its core is a KQL operator that takes key value pairs as input and bundles them into a dynamic data type, which is essentially a JSON object or a bag. To keep in mind, dynamic is a data type which is specifically available in KQL in addition to the other usually available data types. Think of it as creating a mini JSON object on the fly without your KQL query. That's what the Backpack does. The basic syntax is quite straightforward. It's going to be just a key value mentions inside a backpack function. Here, you provide a string for the key, which will become the JSON property name, and any KQL expression for the value. The order of these key value pairs matters when you want to maintain a specific structure, although JSON itself is unordered. It's important to know that Backpack works row by row, creating a JSON object for each row where it's applied. That is, whenever you are going to apply the backpack, it is just going to process that backpack function row by row as shown here. So we will see this in action. For this purpose, I already have a small table which is more like a static table. It has three columns: serial number, name, and email ID. I'm going to add an extend operator here and specify the column name as user info. Then I'm going to say inside backpack have these three columns, and I'm going to statically say the key value is ID, and this ID is going to have the user ID value, which is this column name, the first column name. The second key is going to be name, and that's going to have the value that's there in the username column. My third key is going to be email, and which is going to have the content that is present in the email column. And then I'm just projecting this user info that has got created. As soon as I run this, you see that we have created a bag which is a key value pair, and it's more like a dictionary. In the next example, let's make it more practical to show how we can create JSON array objects with aggregate operators like summarize and list the aggregate functions. Consider our sample data here. We have multiple reviews for the same product. As you can see here, we can represent all the reviews for a single product as a JSON array, which would be more meaningful if you want to use it for some kind of analysis. The key is to first group the data by the entity for which you want to create the array. In this case, it is the product ID. We have a product ID column, then we have a product name, then we have a reviewer name, then we have the date when it is reviewed, and whatever is the rating for the product. And using this, we will use the summarize operator. We can use the functions like make list, make set, or make bag to gather the related information. And within these list making functions, we can also use the backpack to define the structure of each objects within the array. When I execute this, you will see this is returning a table with 5 columns in it. Now I'm going to say that I want to pack the reviewer name, reviewer date, and rating into a JSON array, which I'll then use it for some other purposes. I'm going to add a pipe operator, then do a summarize. Then I'll say I want to create a column called as reviews. In this reviews column, I'll say create a list using the make list operator. And inside the make list operator, I need to provide a specific expression. For that purpose, I'm going to use my backpack operator, which is going to create a dictionary of key value pairs using some of the columns available here. And I'm going to say my first key value is going to be reviewer, and that should hold the value of reviewer name. My second key is going to be date, which is going to be the review date. My third key is going to be rating, which is going to hold the rating information. So this bag has to be summarized by some column, right? So here I'm going to say summarize by product ID and product name. That is, for a combination of product ID and product name, I will be having a single list. When I run this, you will see that I will see three columns here. One is product ID, product name, and reviews. And this reviews is going to have the combination, that is the key value pairs of reviewer name, date, and rating. In the next example, let us see how we can create JSON objects nested. For this purpose, I am creating the similar table, but in this case, it's going to have two more new columns, that is supplier name and supplier city. And when I execute this, you will see this table is returning five columns. Then what I will do is I'll create three backpacks, one for reviews, one for supplier, and one for product name. Since the supply information might be the same across multiple reviews for the same product, we can use an aggregate function like any or first along with the backpack to pick one set of supply details. For the sake of time, I already have these things written and ready. So I'm just going to copy and paste the contents here. So I have a summarize operator here, and this summarize is going to return me three things. One is reviews, which is similar to the one that we built in our previous example. The second is going to be a supplier column. This is going to be a bag of name and city, that is the supplier name and supplier city. The third is going to be for what product name these things are. And I'm going to say group this by product ID. When I run this, it is going to return four columns, one for product ID and the three for the columns that we have as part of the summarize operator. Next, what I'm going to do is I'm going to extend this. How I can extend this? I'm going to add a pipe operator, then extend. I'm going to say create a new column called as product details, and this product details is going to be a pack, and this pack should have the same information that was created as part of the summarize operator. So for the sake of time, I already have this written. I'm just going to copy and paste it. If I execute this, you will see that a new column called as product details has been added, and this product details is going to have the product ID that was part of the previous output, then product name that's coming from the previous output again, and then there is a supplier info key which is going to hold the supplier information that we created in the previous step, and then the customer reviews which is going to hold the information that was created in the review section. Then I'll just say project only the product details. Now you will see we have only one column which is going to be the combination of four different types of information just made into a list of key value pairs. If I expand this, you will see this product details has three other things under it, which is product review, customer reviews, then product name and supplier info. Moving to the next example, we have a table that is written which is returning us three rows. One of the powerful aspects of backpack is its flexibility in defining property names and values dynamically using expression. Instead of hard coding the values for the keys as strings, you can use the content of other column or the result of functions also as keys. Here we have a table. While we do a make bag, we can directly create a dynamic object with dynamic keys. You can achieve a similar dynamic key behavior within backpack if needed, often through more complex string manipulation or conditional logic. Let's see this in action. I'm going to say summarize, then I'll say create a new column called as metric bag, and I'm going to say make a bag, and this bag should have the pack of metric type and metric name, metric type and metric value. If I execute this, you will see this is returning me a metric bag that is going to hold the three rows that is present in the table, one for CPU usage, memory usage, and disk latency as a key value pair. So this pack is going to create an array for each of these three rows. To see this in action, I'll show you this. I'm going to say extend packed column. I'm going to say just pack. If I execute this, you will see this pack has created a key value pair for each of the row. Then make back is going to make those together into a single bag like you see here. So we have been seeing different examples as of now. Let's go one step further and see how we can prepare data for an API using this backpack operator in KQL. So often the APIs expect data in a specific JSON format. You might need to take data from your ADX tables or transform it into a request structure. Imagine an API that expects a list of user activities. So here we have a new table which is having four columns: user ID, activity time, action, and resource. Now, as I said earlier, my API is requesting only two columns. One is going to be user ID and the other one is going to be the API payload. So how can I achieve this? I'm going to again use the backpack operator. For the sake of time, I already have this written. Summarize the value and have my backpack function create a pack and put it into a list, and this list has to be grouped by user id. That is, my user id will be a column and all these three things will be grouped into a list of packed values of key value pairs. If I execute this, you will see I have two columns, user id and user activities. Then I will create one more payload, one more API payload, and this API payload is going to be extending this same thing. Instead, it's going to have this user ID also as a part of the pack. That is, if I execute this, you will see it is going to create a single array which is going to have two key value pairs. One is user ID and the username. The second key is activities, and it's going to store the entire value that's present in the user activities. So we have seen many implementations of Backpack so far. Now it's time to wrap up. Let's see what are all the different tips, tricks, and common pitfalls that we may have to be aware of while using the Backpack. First is be mindful of your data type. You might need to use the functions like toString, toInt, etc. to use the backpack effectively in your JSON array. If a value is null, backpack will also include it as a null in the JSON array. Consider using the if operator or other conditional logic to handle nulls wherever needed. The third is for very large data set, excessive use of backpacks, like we use in one of the example where multiple backpacks were used, one within the summarize, one within the any operator, that can potentially impact the query performance. So you need to be mindful of using the backpack operator with a effective thought on the performance as well. The fourth is readability. For complex nested structures, format your KQL query clearly with proper indentation. So what are all the pitfalls? The syntax of backpack is little misleading, so you need to properly check the syntax while writing the backpack operator. And unexpected aggregation is one other pitfall. So when you are grouping the data correctly before using summarize with make list or backpack, you need to avoid using the array contents. So that's all in this video. If you like this video, please like, comment, and subscribe for more similar videos.